All right, guys. So in this video, we're going to be going over lab number 25, which is going to be on heats of chemical reactions. So when you open this one up, you're going to go ahead and click on this link, and it's going to take you to a simulation that is going to look something like this. So I'm actually going to go ahead and just refresh this whole thing. So let me show you a few things that you can look at. When you open this up, you're going to get this overview, learning outcomes. Now you can just go ahead and click on experiment when you run this. Now you have two options, run demonstration, run experiment. I'm going to click on run demonstration first, but for you guys, don't click that. I just want to show you in a lab setting, typically what we would be using would be a styrofoam cup as our calorimeter. And we wouldn't even really have stoppers on them just to prevent any heat going in and out. Realistically, if we were to do this, it would just be a styrofoam cup and a temperature, a thermometer to measure the temperature change. So that's like a typical calorimeter that you would use in a lab. This simulation is all going to be based off of actually using a legit pressurized calorimeter. So basically, you have no external temperatures being applied, no pressure changes within the system itself. So all of this is going to be underneath ideal conditions. So we're going to get some really good data out of this. So let me show you again what this is going to look like. So you're going to open up the lab and look on calorimetry, look on experiment, and then we're going to run it. So let's kind of walk you guys through what you guys will be doing. And there's a couple of things here. So we check out the kind of purpose. We're going to look at the heat of reactions of two specific heat reactions. We have a calorimeter, a thermometer. We're going to use ammonium nitrate, 1 molar HCl, and 1 molar sodium hydroxide. So the first procedure is going to deal with this ammonium nitrate, which is going to be pretty simple, but let me kind of walk you guys through the setup. So we're going to select the solid icon and choose ammonium nitrate as your solid. So what this is going to look like, you have to go here, click on solid. We're going to find the ammonium nitrate right here. And then we got to add some values. So basically what we have to do is find 25 grams of this ammonium nitrate. So we're going to select 25 grams, which is basically all the way up just to keep it simple. And you can show your delta H in this case, but we don't really need to. So let's kind of click and you can't change the temperature because it's just assuming it's at room temperature, at 20 degrees Celsius. We're going to go and click on next. And then we got to choose a liquid, and we're going to select water and then hit next. Now we're going to go and hit liquid. We'll do water. And actually, I should clarify this. We should set this water to, I'm going to set it to 100. Let's do 250. And I'm going to change that for you right here. Select 250 grams. Select next. Okay, so we're going to use 250 grams of that water, and then we're going to actually hit next. So we got 250 grams of water in our calorimeter. We're going to add this ammonium nitrate to it. We can go ahead and show the specific heat of water. Now, we can actually start the lab, and it's just basically going to tell you that when you add your solution here, it's basically going to show us the temperature change of the water. Okay, so we're going to go ahead and you can show the graph. I would advise you do that, so it's going to help you determine if it's an endergonic or exergonic, or endothermic versus exothermic, excuse me. So when you start this, basically it's showing you're putting your ammonium nitrate in, you're sealing it, and this is measuring the temperature of the water. So notice your temperature of your water is rapidly declining. So the temperature of the water goes down, and it should end here pretty quickly. It only takes a few seconds. And the reason why we have to do this is we got to get our final temperature. So it looks like the water started at 20 degrees, and now it went down to 13.03 degrees Celsius. So I do want you to make sure that when you're doing this, you actually submit your temperature as your data. So we don't have a data table. We can just record this as 13.03. So we'll just do 13.03 right here for your guys' data. And that's basically going to be part one. Now, I'm going to jump just down real quick to show you the calcs for part one. Calculate the temperature change in the system. You just want to remember it was initially at 20 degrees. It went down to that 13.03. calculate the heat transferred by the water in kilocalories. So just be careful. In this case, we're using the mass of the water. So the mass that we actually did on this one was 250 grams. So keep that in mind. I'm having you guys start that mass of the water at 250 grams. And basically, you're going to be solving for the moles of your ammonium nitrate. So you got to figure that one out. So we actually started out with 25 grams of that ammonium nitrate. You actually have to convert that into moles. And then we're going to calculate the enthalpy for the reaction. And remember, you're doing this one in kilocalories per mole. So you're going to take what you got for number 2, divide that by what you get for number 3, and that will be your answer for part 1. Okay. So part 1 is pretty straightforward. And then we can get into part 2, where we're going to have sodium hydroxide and hydrochloric acid and mixing those together. So here's your equation. Now you're going to jump back to this. Now it doesn't really let you, if you reset everything, yeah, okay, so that's good. You can hit reset or just reload it again. But in this case, if you follow the instruction, we're going to select solutions. We're going to have sodium hydroxide and we're going to have hydrochloric acid. We're going to add 100 milliliters of each at 1 molar. So let's show you how to do that. So we got solutions. We have we'll do our base first. We'll do sodium hydroxide. I suggested we did 100 milliliters. So you just got to be a little patient here. It goes all the way to 100. That's nice and easy. So you just run that bar all the way across. The molarity for this is, I'm telling you to set it at 1. So we have 1 molar sodium hydroxide. We're going to go and hit next. Now we're going to choose our other liquid. Now notice if you try to add a liquid, you can't do anything. So you have to actually go to solutions. So in this case, we're going to be adding HCl. We're adding 100 milliliters of that. And I suggested that we did 1 molar of the HCl as well. Okay. So we're going to run this experiment. But before we do that, we actually have to hit next. As soon as this bar gets out of the way. I'm going to go ahead and show the graph. So basically, we're going to mix these 2 aqueous solutions because these are mixed in with water. And we're going to see what happens to the temperature of the water and see what happens with it. So mixing these 2 together, we're going to seal it. I now have a total volume of 200 milliliters of water. And notice that the temperature of the water has risen. Okay, so initially it was at 20 degrees, just like before. It defaulted to 20, and now it's going to keep on climbing all the way up to 20. As soon as it stops, you'll probably it looks like it's slowing down right here at about 26.81. So that would be your final temperature for this one. So you would record that as your temperature final. So temperature of the water definitely increased. So you got to figure out if that's a exothermic or endothermic reaction. So you're going to record that, and then your calculations on this for part 2. Calculate the temperature change in the system, similar. Calculate the heat transferred by the water in kilocalories. Actually, I'm going to change this. I'm going to have you guys do this in kilojoules. So kilojoules. So just because I want you to have something a little different on this one. So we're going to keep it at kilojoules. So remember, the chemicals are in the water, so the water absorbs or loses energy. And I'm telling you, the total mass of the water was 200 grams. The reason being is because we had 100 mils of your HCl and 100 mils of your sodium hydroxide, giving you a total volume of water of 200 mils. And I even remind you here that 1 milliliter of water equals 1 gram. So that's how we did that conversion. So use that to calculate the heat transferred in kilojoules. And then we're going to calculate the moles of sodium hydroxide. And I tell you this, that 100 milliliters of 1 molar sodium hydroxide contains 4 grams of sodium hydroxide. And then you're going to calculate the enthalpy. So that's how you would do this calculations for part 2. Follow along with the video notes posted if you have any issues on what's happening with those. Now for the questions, classify them as endothermic or exothermic. Rewrite the equations for both. Make sure you include your heat values on the reactants or product side accordingly. Remember, if it's endothermic reactants, your heat goes as a reactant. If it's an exothermic, you put the heat on the product side. In question number 4, you're just basically answering that directly. The discussion of error here is going to be a little different. This is just for us to see if what you guys would think if we actually did this lab with the traditional calorimeter. So What I'm asking you guys to do here is when you did the basically, if you were to do this in a lab setting and take away this, because we wouldn't even have the lid on here, you're answering these questions according to if we did the lab, which is one of these typical styrofoam calorimeters. So if you have any questions or issues on that, if these are the causes, how would it affect your values and your calculations, okay? So if you spilled some HCl in part 2, how would that impact your question part 2? Now, we did have an excess of HCl, so that's kind of a hint there. Or if you had a hole in your calorimeter, how would that impact things? So basically, you just we're trying to see what you guys would have thought if we did this lab and any errors we possibly could have ran into. And then kind of use this as your reflection. How could a styrofoam cup calorimeter be improved? Basically, just kind of compare and contrast, like why is this one far superior to a calorimeter that's just typically in an open styrofoam cup? So that's the lab setup. Everything that's in red you are accountable for, and that's what we will be looking at. Yeah, feel free to reach out to us if you have any questions about this lab.